Centre of gravity. Here we have a beam balanced off centre by having a box of weight W1 on the left hand side. The weight of the beam will act along the entire length, but we can simplify the situation by assuming that all the weight is acting through this point. If the beam is uniform, this will be the centre of the beam. This is the centre of gravity of the beam, and the centre of gravity of a body is the point through which the entire weight of the body appears to act. For a uniform object like the beam, the centre of gravity will just be the centre of the object. But if we're asked to find the centre of gravity of a more randomly shaped object like this, we can freely suspend it, and the centre of gravity will lie directly below the point of suspension. So if I suspend the object from this point here, it might hang like this. If we use a plumb line to find the vertical line below the point of suspension and draw a line on that point, we know that the centre of gravity is somewhere on this line. Now if we suspend the object from a different point, the centre of gravity will be somewhere on this line as well. So we know that the centre of gravity lies on both the lines, so it can only be where the lines cross, and this point is the centre of gravity. This method would work in principle for three-dimensional objects, but might be more difficult to carry out in practice. The centre of a gravity might not actually lie within the body itself. For instance, if we had a shape like this, the centre of gravity might be around about here.